Hello and welcome. In this video, we are going to be discussing diffusion and osmosis. At the end of this lecture, you will be able to define osmosis and diffusion. Also, you will be able to explain osmosis and diffusion to a 6 years old, meaning you are going to have a deeper understanding of the concepts. Also, you will be able to differentiate between osmosis and diffusion, and you would also be able to explain why do we have diffusion in one case and osmosis in the other case. Now, what is diffusion? Diffusion is the movement of solutes in water from a region of higher solute concentration to a region of lower solute concentration. So, in essence, what we are saying is that in a solution, we have the solute and we have the solvent. So, for example, sugar in water, sugar is the solute and water is the solvent. Salt in water, salt is the solute and water is the solvent. Also, we have dye in water and we have many other solutions. So, when you have the solutes being dissolved in the solvents, the solute begin to move around from region where there is more of it to region where there is less of it, or to region where it does not exist before. So it begins to move around until there is like equal concentration of it across all region. So we can say diffusion, another word for it is to extend, for something to spread, across all region. So that's diffusion. Now let's look at two examples. We are going to be taking an example in the case of liquid, diffusion in liquid, and we also look at diffusion in gaseous state. So diffusion in liquid, look at these three things here. We can call them solids: dye, sugar, salt. We have a long list of what can be solids. So this is a cup of water here, and this cup of water, let's say you throw either a cube of dye, a cube of sugar, or a cube of salt. Just throw the solute in the water. What I'm going to have is that this point is the point where there is higher solute concentration. And these other places where there is just water, these are points where we can say there is lower solute concentration. It doesn't have to be just water. They can, as you are dropping the sugar or you are dropping the salt, it's already going across this path, these places. But at least you cannot compare the concentration to the actual point where you are seeing the cube of sugar or you are seeing the salt particles. So what is going to happen when you drop this? Diffusion will begin. Then the sugar or salt or dye will begin to move to other parts of the cup, other part of the water in the cup. Then at this point, you can have a non-evenly distributed, the distribution is going on, but it is not even. You can taste a sugar, you can taste a solution of water and sugar, and then you can just take a part and you feel like it's not sweet enough, and you take it again, then you now feel like, okay, it's now getting sweeter, because at that point, the division is taking place, but it's not actually even. It's not everywhere yet. It's not everywhere at the same concentration yet. It's just getting to those points. So we can say that is what is happening here. Then we have a point where there is even distribution of the solutes across different region of the water. Also, we have diffusion in gaseous state. In this case, let's say this man right here, let's say he farts or he open a rotten food or apply air freshener. Definitely at this point we can say this is the region of higher concentration. So this region, maybe like 2 to 5 seconds, people here can begin to perceive the odor. It means that the particles here is now flowing in the air until it gets to this point. You cannot expect the concentration here to be the same with concentration here. So let's call this moderate concentration. Then maybe another 2 to 5 seconds, it gets to these people here, we can say, it has spread even further. Then we can say this is low concentration. So that is how diffusion occur. It wants to take a solute or take a particle and spread it as much as it can. In the case of water, it can only spread to the point where the water ends. So if you have a cup of water, it can only spread to the water in the cup. But if you have a diffusion in gaseous state, so it wants to keep spreading it, you know, into the atmosphere. So now we have osmosis. Osmosis is more like a reverse of diffusion, but not absolutely reverse. Osmosis is the movement of solvents, such as water, through a semi-permeable membrane, something that permits one thing but does not permit another thing to pass. For example, like the membrane of living cell. So movement of a solvent such as water through a semi-permeable membrane into a solution of higher solute concentration. Now, at this point, we can say this is the end of the definition if we want to. But just to make more sense, why is it doing this? Because it tends to equalize the concentration of solutes on the two sides of the membrane. So look at this diagram here. You have a semi-permeable membrane. This right here is a semi-permeable membrane. So it can allow one thing to pass while not allowing another thing to pass. In this case, let's call all these cubes, let's call it our solutes, probably sugar, anything you want to call it, just call it, this is your solutes. And let's say this is the water level. Let's say we just pour the water and added these cubes. But look at this side, you have 4 cubes. On this side, you have 8 cubes. So normally, we know that these two sides, let's say side A and side B, they don't have the same solute concentration. This here have higher solute concentration and this here have lower solute concentration. What we are now saying is that in the case of osmosis, because these have higher solute concentration, more of the solvent is going to move. So it's a movement of solvents. Movement of solvents. More of this solvent is going to move to this side. More of the solvents from this region of lower solute concentration. You have only low. We have 4 cubes here. We have 8 cubes here. More of this solvent, more of the water here will move to this region that have more solutes. So that at the end of the day, these two sides will have the same concentration. The same concentration. So for simplicity's sake, let's say this is 75 Cl mark. Somewhere here you will have 100 Cl mark. Somewhere here we have, let's say we have 50 Cl mark. So come to the next slide. What are we going to have after osmosis has taken place? What happened is that, let's say all of these things, I'm just putting it there for the sake of illustration, but normally they have dissolved. You might not see them with your eye unless in the case of dye, and you will not see it as a cube like this. So, recall, we call this 100 Cl mark. Let's say somewhere around here is 75, somewhere around here is 50. So this 100 Cl mark, let's say it is what traced to this point here. So this is what happens. This solution right here, when you compare to the solution here, it has higher solute. So you can say it is hypertonic. The solution here, it has lower solute compared to the solution here. So you can say it is hypotonic. So, but what osmosis wants to achieve is isotonic solution. So in this case, let's say this um, compartment A, this compartment B. This compartment A water level rose from 75 Cl mark to 100 Cl mark, while compartment B fall from 75 to 50. So if you look at it, okay, this one have 50, this one have 100, and this one have 8 solutes, this one have 4 solutes. The equation is balanced. You understand? Because now they have the same concentration. That is what osmosis wants to do. It wants to ensure that, okay, since solute cannot pass, let the solvent pass, and at the end of the day, let's have the same concentration on both sides. Do you get it? So, what if the pore size is bigger? This pore size of this semi-permeable membrane is bigger, such that as this solute now dissolve, they can pass through it. The answer is simple. Instead of having osmosis, we would just have diffusion. It will be the solutes. There's going to be a net movement of solutes. At the end of the day, we should have net movement of two of these here. So at the end of the day, we have 6 here, we have 6 here. Water level remain at 75 on both compartments. Yeah, I enjoyed this. So if you like this video, if you have any question, kindly drop it in the comment section. If you like this video, thumbs up and subscribe for more videos like this. Share with your friend. Peace out.